So we'll go ahead and get started here. A couple things to address up front, and then we'll dig into some code. For those of you who aren't necessarily familiar with the concepts of a tile engine or what that really implies, I've got a few terms that I'm going to be using throughout the talk that I wanted to define up front. And the first, of course, is a tile engine. So a tile engine is basically a technique that that a game developer would use to create the impression of a much larger graphic by reusing a bunch of smaller graphics together. And so this technique was first really designed when game consoles and computers didn't necessarily have a whole lot of memory, and especially back in the old cartridge days where you had a very finite amount of memory, and so game developers would use little tricks like this to pack as many resources as possible into a very finite amount of memory. And the principal concept behind the tile engine is that you could have a huge map but only have a handful of graphics, because if you had a large area of grass or a large area of mountains or sand, chances are you didn't really need a whole lot of variation in detail. And so you could create one small tile to represent grass and another one to represent sand or water, and then just have that one asset in memory but display it over and over and over to create the illusion of a much bigger map, which brings us to tile map. The tile map in memory is represented as a two-dimensional array or matrix, and typically your tile map is going to contain a reference to a tile object. And for gameplay purpose, or game development purposes rather, a tile object is usually going to hold information about what's going on in that particular space on the map. And so it might have information about the actual location on the map as far as what type of terrain is it. Is it woods? Is it desert? Is it a wall? Is it a door? Is the door open or closed? Is it a pit full of spikes? Am I going to take damage if I try to walk over it? Can I walk over it? Do I have to go around it? Does it provoke collision detection? That sort of thing. And so in addition to all that information about the state of the game in relation to that location on the map, a tile would also contain information about what image to use when displaying it on screen. And so for purposes of our demo today, I have borrowed a set of tiles. I am no artist, and anyone who knows me can vouch for that, especially if they've seen my work. So what we have here is a collection of tiles that are freely available on the web for people who like to build games, but you can't use these tiles in your finished product. The idea here is that when you're prototyping a game, if you're a developer like me, chances are you don't want to spend 60% of your time trying to come up with graphics and not being happy with the way they look and everything else. You just want to build a really cool prototype quickly. So there's a number of different sites out there that do this, but Lost Garden is one of my favorites because they have a lot of really good articles about game development and design, and they have a couple of different tile sets that they've made available for people to download and use while prototyping. So this lets you build out your concepts and your gameplay and still look fairly cool, and so when you show it to your friends, they're not like, oh yeah, whatever. You know, you actually have something pretty cool looking, and then you can take it to an artist and go, okay, I built this fantastic game, but now I need good art. I need real production art and not just placeholder art or borrowed art in the case of this. And so we're using a few tiles in our demo. We've got a water tile, a grass tile, some dirt, a stone tile, and then a tree and a rock. And those aren't necessarily tiles, but I'll explain that in a little more detail once we get going. We've also got a couple examples of how different types of games could use the same tile set. So on the left we have a simple RPG map with a couple of characters roaming around, and then on the right you have what would be referred to as a side-scrolling platformer, where instead of laying the tiles out in a flat arrangement, they've actually stacked them to create obstacles that you have to jump across and that sort of thing. So if you're listening to this later and you want to go through it and actually build out the demo as I do, you can get this particular tile set at lostgarden.com/planetcute_png.zip. And the space is important. There's also another one called Space Cute, I think, which has got little spaceships and planets and stuff. And again, it's for prototyping other types of games. So with that out of the way, we know what tiles we're going to use. We've got a rough idea of what we're going to do. And so we'll go ahead and get started by jumping into Visual Studio. And so the first thing we're going to do is we're going to create a Windows Phone game project, just like you've seen before, and we'll just call it Tile Demo. We'll go ahead and create that. Excuse me. Now, before we get into the game class itself, we need to do a couple things. So we're going to add a class to our project, and we're just going to call that class Tile Map. And this is where we're going to store a lot of information about what's going on in our tile map. The first thing we're going to do is we're going to create a set of constants that define a little bit of information about the tiles we're using and the borders of our world, and I'll explain what those are in just a moment. I'm assuming you guys don't want to sit here and watch me type, so I've actually got the code prepared a little bit, and I can just paste it in. So the first block here, this deals with the actual size of our tile images. So they're 171 pixels high by 101 pixels wide, and that actually includes a little bit of transparency at the top, which when you see them, you'll see why. And then the second block here, we're going to be adding a layer of dirt underneath the main area of the tile map. And so we're kind of faking it out. We're not using the entire tile. We're just going to use part of it. So I've set the height a little bit smaller, and this is going to let our code just grab the piece of the tile that we need in order to display it. And that may not make a lot of sense right now, but when you see it in action, you'll be like, oh, okay, I get it. I see what he's doing. And then we've also got some code here to help with the calculations to make sure that when we're moving our tile map, because remember, this is a scrollable tile map, and so we need the engine to know how many tiles wide and how many tiles high you're actually going to be displaying on screen, and this will help with our calculations to make sure the camera doesn't go scrolling past the edges in any of the four directions. And then the last four here, these are used to help define the padding around the world. So right now I've got it cropped in pretty tight, so you can scroll around up to the edge of the map, but you can't scroll past it into the nice cornflower blue background that exists everywhere else. And we can tweak these values a little bit if we wanted to be able to scroll past the edges of our world. So with those out of the way, the next thing we need to do is we're going to go in here and we're going to add a vector 2 that will hold the actual position of our camera relative to our world. So we'll paste that in here. And there we go. So we've created camera position, and what I've also done is I've gone ahead and populated it with a position that's going to effectively give our camera a starting position when we first load up our demo, and it's going to be in roughly the top left corner of the map. And the way you can tell that is that you know that we've got an array that represents each square of the map or each tile, and so we're taking our position in an array times the width of the tile and times the width of the height, and using those as our camera position. So we're translating from position 2,3 to position 242, 303, for example. And so with that out of the way, we need to also add a list which will contain our tile images. So we'll put that right under here. And this is going to store the texture 2Ds that result from the loading up the actual art assets. And then we're going to set a few properties. We're going to provide a property for the height of the map itself and the width. We'll go ahead and add these in. And these will come in handy when we're trying to figure out stuff in regards to moving the screen around and what we're going to be drawing and that sort of thing. And so right now we don't have a map object defined in our class yet, but we'll get to that very soon. So just bear with me on that one. Next thing we need to do is we need a way to load the actual art assets into this class. And since we're going to contain all of our art assets in this class, in the tile textures list, we want a way to load the textures from our game class. And so the way we're going to do that is we're going to add a method called add tile texture. And so this way we can call this from our game class and pass in the texture 2D that we load up during the load content method. Now, since this is a scrollable tile engine, we need a way to actually move the camera around within the limits of our world. So we're going to create a move camera method. And what this does, this is going to take a vector representing the camera direction. And the way we're going to move around is with touch. And so for simplicity's sake, I am going to be adding code in a little bit that checks to see if a free drag gesture has been performed. And then we're going to take the delta of that free drag gesture and we're going to apply it to our camera, and it's going to move the viewable area of our camera. Okay. Next, we need to add some code to draw the tiles, of course. So we'll add a draw method to our class. Go through this a little bit. So we're taking in a sprite batch, and what we're going to do here is we're going to loop through the X and Y of our map, and we're going to take a look at each cell of our array, and we're going to figure out, based on the tile width and the tile height and the camera position, whether or not we need to draw certain tiles, and then we're going to figure out what's stored in the cell of the map. And so this will make a little more sense once you actually see the map, but effectively we're going to have an integer in the map that represents a texture. And let me go ahead and clear up a couple of these issues real quick. We've got it's looking for a namespace here. Hang on just a moment. Let's resolve this. Where did it go? Well, we know what we need to add. I'll just put it up here in the top. So, using Microsoft.XNA and whoops, sorry, dot framework. There we go. This should get rid of some, and then we also need one for graphics as well. So, using Microsoft.XNA graphics. All right. So, give that a chance to clear up. And then we're going to, so once we get into the draw method, it's going to loop through the map, and it's going to look in each cell of our map array. And so if we have a 0, it's going to draw one type of texture. If we have a 1, it's going to draw a different type of texture. We've got a little extra bit of code here because, as I mentioned before, with the dirt, we're not going to be showing the full tile. We're actually only going to be showing a part of the tile because it's going to be layered. And so we do something a little different for the dirt. Instead of just drawing the tile as is, we're actually taking a source rectangle from that image using the offsets that we defined up above, and then just pulling that part of the image and then drawing that on screen. And then finally, if it's not the very top row or the dirt row, then we just take the tile as is and draw it on the screen. And so now if we switch over to our game class, it looks like we're still missing a namespace. Hang on one second. Let me make sure I'm not missing anything else. My mouse is apparently going crazy. Here we go. 1 second. Graphics framework composition. Okay. Interesting. All right, so we'll just get back to that in just a moment. So the next thing we do is we switch over to our game class. Let's save this. Let's save. There we go. Switch over to the game class, and we need to add a reference to our tile map class that we just created. So right here, we'll go in and we'll tile map equals new tile map. Okay. Oops, we're going to need these. There we go. And then in our game constructor, we need to set the screen dimensions because if you remember, our map is actually going to be bigger than what's being shown on the screen, and so we're going to adjust our back buffer width and height to the new dimensions. And so we'll go ahead and add that in. And so we're taking the width of our tile map, which is the array, and the height, and then we're multiplying it by the actual size of our tile images, because that's going to be our overall image, or our back buffer rather. And as I mentioned earlier, we're going to be using the free drag gesture to actually move the map. So we're going to add this line into the initialize method of the game class. So we'll go in here and we'll set our enable gestures to free drag. And remember, XNA only checks for whatever gestures you've actually enabled. And so with this being the only one we've set, it doesn't really matter what we do on the screen. It's only going to do something if it finds one of these. So now we need to add the graphics for the tiles. And so we're going to go into our Solution Explorer and into our content project. We're going to create a folder, and we'll call that tiles. And then we're going to add some graphics into that folder. And we'll go out here and grab our items here. So we're going to get the dirt, and we're going to get the grass, and we're going to get, and you can see there's a bunch of different tiles here to choose from besides just the ones we're using. We're going to get stone, and we're going to get water. We'll go ahead and add those in. And then in our load content method, we're going to actually add some code to load those in. And because we created a method in our tile map class, we're going to call the add tile texture, and we're going to load in each of the four. And you notice we have to specify the folder name and // because of the escape character, so that way it knows where to look to find the right images. And we use the content.load, and we're just passing it right into add tile texture of our tile map, which in turn will stick it in our texture list in the tile map class. Okay, in the update method, still in our game class, we're going to check to see if a gesture is being performed, and then we're going to adjust the camera based on the difference between the start and end points of the drag. We don't need to actually check the gesture type since we're only supporting free drag. We don't need to specifically say if it's a free drag. And so we'll go ahead and add this code in. One moment. And so this checks to make sure there is a gesture available. And we need to add this namespace as well. Nope, it's already in there. Okay, excellent. So one thing you'll notice is when we're passing in the delta here of our gesture, and so the delta, of course, is the difference between the start point and the end point. And when we're passing in the delta, we're actually reversing it. That's what this minus sign right here means. And the reason for that is because this way, if you drag your finger to the right, the camera is actually going to move to the left, which makes it look like the world's moving in the right direction. If we didn't do this, the movement would actually be very confusing to the players. So we have to flip the delta and then apply that to the camera. And so you're basically taking one vector 2 and adding it to another vector 2. If you remember the soccer ball demo from the XNA webinar, you can do movement if you have two vector 2s and one represents a position and then the other represents velocity or the direction of movement. And so you can actually add the one vector 2 to the other, and then that gives you a new position, which is your location plus your speed. And then that way you can update the vector. So the last thing we need to do is we need to add the code to actually call into our tile maps draw method. So we're going to go into the draw method of our game class. And right here, we'll go ahead and add this in. And it looks like we have a question actually. It says, I'm sorry, but I forgot what the offset means. Can I briefly explain it? Oh, absolutely. So with the offset, if we go back into our tile map class, up here, the offset is going to be used because we have our tile height and our tile width, but the tiles that we're using, and the best way to explain this is just to show you one, they actually have a little bit of a transparent area at the top. And so that offset, in this case, we don't want to draw one tile directly below the other tile because there will be a huge gap in between each tile. And so the offset in our case is the amount of space that's transparent, and when we draw the tiles, they're actually going to overlay each other by the amount of the offset, but it's not going to look that way because that amount is transparent. And this allows you to layer it just right. And also, if you look at the tile here, you can see that there's a surface to the tile, and it's kind of a fake 3D, right? There's a surface to the tile, and then there's also the meat of the tile. And so imagine this as a three-dimensional piece of dirt. So you've got the clear space above, and then you have this area here, which represents the depth of the tile. And so we don't want to draw that. We don't want to draw our tile below that either. And so we're actually drawing the tiles where they meet up right along this line here. And so our offset gives us the ability to adjust where the tiles are being drawn. So now, since we're in our tile map class, let me go back and save our game class real quick. We're in our tile map class. We need to go ahead and add a map. So we can't run it just yet because there's no map. So what we're going to do, we'll go ahead and add in our integer array. We'll just call it map. And we're going to initialize a bunch of values for that. I'll put it right here. And so if we take a look at this map, there's kind of a lot going on here. As simple as it is, all these numbers have meaning. So we talked before about when we're drawing our tiles, we're going to be looking at the map, and in a more complex example or in a real game, instead of having a map that's nothing but integers, you would probably have an array with some type of custom game object. And so that game object would store information about each tile. And so it may be something like causes damage or prevents movement or has a door and whether the door is open or closed. In addition to this tile is grass or this tile is stone or this is the bottom left corner of a house or anything like that, you can actually store a fair amount of game information as well. But for the purposes of our demo, we're strictly just storing tiles here. And so if you go back and look in the game class where we actually added our tiles, we added them in a specific order. And so our grass block is 0, our stone block is 1, our dirt block is 2, and our water block is 3. And so if we go back to the map and look, you can see based on that, got a bunch of 3s around the top left and right border. So you know that our map is going to be surrounded by water, because water was 3. We've got a lot of 0 in here. 0 was grass, so we've got a fairly grassy field. 2 was dirt, and so you can see we've got a layer of dirt that's actually going to show up below the water and the grass. And then we've got this little squiggly pattern of 1s here, which represents our stone path through the world. And so Now, unless I'm missing a namespace somewhere, we should be able to run it. Oops, hang on. It's trying to go to the phone. Let me switch it over to the emulator. That's my fault. Okay. It looks like my emulator is a little confused. Let me go ahead and close the emulator and then relaunch. And that happens sometimes if you're using multiple instances of Visual Studio, your emulator gets a little confused. And so that's pretty normal. And so what we have here, here's an example of our tile map as it is. And so we've got a nice little border of a couple squares of water around the left and top. And you can see here's our grass. Here's our stone path. And I'm just doing a free drag gesture to move it along. And it's not terribly fast, but we can certainly tweak all of that as well. And so then on the bottom here, we've got a layer of dirt, and you can see that we're only drawing a section of the dirt tile. So it looks like, for example, the grass tile or the water tile is actually stacked on top of the dirt tile instead of just edge to edge with it like the two grass tiles. And the way we're doing this is when we make our draw call for that bottom row, which let me flip over here. Oops, that's our game class. Flip over here, where I mentioned we're doing something special for the dirt. That's what we're doing. We're actually providing two rectangles. One is where we're going to draw it, and the second one is our source rectangle, which this is the one that specifies that we're only using a portion of the source image. And so our dirt offset, in this case, is going to be telling it where to start drawing, and then the width and the height of the piece of dirt, so to speak, that we want to grab. And so that's why we have just this little dirt here. Another way to do that, if we wanted to, is we could add a whole extra dimension to our map, because maybe we want more than just dirt. If we have any Minecraft players listening, I'm sure you're familiar with the concept of having a fully realized three-dimensional play space where you can dig down into the ground and maybe find different types of terrain below the grass. And so if we wanted to, and I'm totally cheating here because I'm just drawing the dirt layer on the bottom, but what I could do is have an array that represents this level as well. And so maybe it's a little bit of dirt, a little bit of rock, maybe there's some water, maybe there's even just open air. And so if you were to build a cube of a tile map instead of just a flat two-dimensional tile map, then you could actually populate that cube with whatever terrain you wanted to down in the ground. And so perhaps you could make a game where people could dig down instead of just walking across the top, and they could expose dirt and then rock and maybe find some gold or whatever. You could have a little 2D scrolling Minecraft right on your phone. For those of you who haven't tried Minecraft, by the way, I highly, highly recommend it. Awesome game. Very cool. Okay, so this is a very basic two-dimensional side-scrolling tile map. Now, I want to take it a little step further because we can do more with it. Right now, it doesn't really do anything other than display our tiles and allow you to scroll around a little bit with your finger. So I want to introduce you to another concept called decals. Let me go ahead and close this. Let me stop this. Okay, so decals are additional things that show up on your tile map. And so where a tile is typically a piece of terrain, such as grass or stone or part of a house, a decal is just decoration on top of that terrain. And so we're actually going to use a separate map to represent our decals. And that's just one way of doing it. There's a number of different ways we could do it. But that's, for demo purposes, it provides a nice illustration of how you're doing it. But you could actually randomly apply your decals. You could have one map with multiple layers. And so what we're going to do is we're actually just going to create another array that stores all of our decal information. But in a more complex scenario, you might want to actually have multiple layers to your tile map. And so we talked about that a little bit before, but not just layers of tiles, but actual layers where maybe you track things like collision detection in one layer, and you track things like monster movement in another layer, and your decals could be in yet another layer, or you could have special magical effects. Maybe you have an RPG where you cast a spell that affects a certain area on the map. And you could have a layer that keeps track of that information, like fire or ice or whatever. So in order to implement decals, we need to add another list. And so technically, this isn't really necessary. You could store your decals in the same list as your tile textures, but I prefer to have them in two separate lists just because it's easier for me to keep track of what's where and what's what. And just like with the tiles before, we're going to need a method to add them from our game class. And so we'll go over here and we'll add another method right after this one called add decal texture. And it works the same way. It's going to let you pass in a texture 2D from your game class, and it's going to add it to the decal textures list. Now, in order to support the decals, we need to add some additional code to our draw method. So we'll go ahead and do that now. So what we're going to do is we're going to stay inside our loop. So we've got our XY loop where we're going through one column from top to bottom, and then we go over one and we go down the next one, and we're drawing all the tiles. And what we're going to do is right here inside our inner loop, I'm going to add a little more code. And so this one's going to draw the decals. What is it missing? Why is it? Hang on one moment. Oh, I know what it's missing. I haven't added the map yet. Okay, so it's going to look at the array that we create for our decals, just like up above where we've got map. This is going to be decals. And then it's going to look to see if there's a -1 value, then it's actually going to dump us out of this iteration of the loop because it doesn't need to draw anything. We're going to fill our map with -1s and then just put actual values for our decals in the locations that we need that will correspond to the regular map. And so if it hits a -1, it goes, okay, I don't have to draw anything anyway, so I'm just going to do the next pass on the loop. And then it's going to take the decal textures list, and it's going to look at the index of the item that's in our map array, or excuse me, our decal array. So if there's a 1 there, then it knows to grab texture 1, and if there's 0, it's going to grab texture 0. And then we're going to draw that decal that we pulled out of our list, and the information based on our current position, or rather our position in the relative world, along with the tile width and height, because we're passing in a rectangle. And so the last thing we need to do for this is we need to add the actual array to store our decals. And let me grab that. And this one's kind of a beast because it's got a little bit more data in it in terms of screen space. Not any more data otherwise. Go ahead and paste that in. And so this is our decals array, and again, it's all just integers. And -1 means that we're not drawing anything. And you'll see there's a few zeros sprinkled in here, like here and here and here. And if you go back and, well, we haven't. Hang on. We haven't. Okay, we need to make sure and add our decals in the game class. But once we do that, you'll see that. So the zeros are going to represent the tree, and the ones, there's a few ones in here, like there's one here, and so I want a second to go up here, but you get the idea. So the ones are going to be rocks, and the zeros are going to be trees, and the rest we're just not going to draw anything because we'll have our map already. So we'll go ahead and close our tile map, and then we need to go back into our Solution Explorer, and we're going to create another folder. And we're going to call it decals. And then we're going to add a couple of decals in there. So they're going to be part of the same set that we got from Lost Garden. So we're going to grab the rock, and we're going to grab tree tall. We're going to add those in. And then in our game class, we need to add those in. And I will just, I'm going to head that in my ready code. We'll just paste it in because apparently I know. So we're going to add Decals Texture. And instead of tiles, we're going to look in decals. We're going to add in tree tall. And we're going to add in rock. Make sure to fix that folder as well. And so with our trees being position 0 and our rocks being position 1, then if we go back into our tile map, you can see where we're going to have the positions of those. And so at that point, we don't actually have to add anything else to our Game 1 class because we've loaded all the content here. Our update is just checking for the gesture. Our draw is just calling the draw method of our tile map class. And so all the real heavy lifting is going on here. We added the decal map here. And then we added, of course, we added our list for the decals here. We don't need to do anything different for move camera. And draw, we added the one section of code here, which draws our decals after it draws. And this is important, okay? It's making a draw call for the decals after it draws the tile. If you do that in the wrong order, you're not going to see your decals, because if they get drawn first and then the tile gets drawn, well, the order matters. And so whatever gets drawn last is what's on top, right? So you want to make sure you draw stuff in the right order. So now if we go ahead and hit F5 and we switch back over to the emulator, you'll see we've got some trees drawn on the grass. And if I scroll over, find a rock here. And so we've got a rock and a few trees. And so that would be how you would do decals. Now, one thing about decals is you can actually provide information about those as well. And so you could treat this the same way you do your tiles, where certain tiles might prevent you from passing or might affect your speed. Maybe you have a mud tile that makes you move slower, or maybe a conveyor belt tile that's animated that makes you move faster. And so you can actually do the same thing for your decals as well. Maybe certain decals you can just pass through, like a tree. If drawn a certain way, you could just walk right under the tree, no big deal, because even though it's in that square, it's not blocking you, whereas a rock might prevent you from walking through there. And so you can store that kind of information. Or maybe certain decals have treasure under them, and so if you jump on the rock and it breaks, then there's some gold there, or whatever. And so managing the game state is entirely up to you, but this will get you up to the point where you're actually displaying everything on screen and moving around. In our next webinar, we're going to take the same example a little bit further and apply some concepts from artificial intelligence about stuff like pathfinding. And so one of my favorite game types is tower defense games. And the way those work is typically you have this seemingly endless parade of monsters that start at one point, say up here, and try to get to the end of the path. And there's actually two different kinds of tower defense games. There's the free-form ones, and then there's the path-based ones. And so for a path-based one, they're going to start at one end, and they're going to follow the path and try to get to the other end. And your goal, your mission, as it were, is to put various types of defense on the map that'll blow up the bad guys as they're making their march towards your home base or whatever. And so with a little bit of pathfinding AI, we can program those guys to stick to the path and not just wander aimlessly around the map. So that'll be covered in the next webinar. But this is our scrollable tile map, and so we'll go ahead and see if there's any questions for this one. It looks like we have one already. Will we be able to download the code after the presentation? Yes, definitely. I will post the code at my blog, and let me go ahead and pop up to the other slide. Where'd it go here? And so this again is our finished product, and we'll get into the question. So yes, if you go to www.blogusmaximus.net, there will be a link to this presentation. Granted, it was only a couple slides, and the code which you can download and take apart and take a look at. I do not own the images, so all of the tiles and decals and everything that you saw are property of Lost Garden, but they are freely available to use in your prototyping. Just don't try to ship a game with them because that might get you in a little bit of trouble. Any other questions?
I don't see any just yet.
Okay.
Posted, but maybe they'll pop in.
No problem. There's a lot of different things you can do with a tile map. Role-playing games, side-scrollers, tower defense. I mean, there's really a pretty wide open set of options. Okay, here we go. What if you wanted to create an endless running type game? You could totally do that. So the way we did it, we had a fixed array with a fixed map, but there's no reason that you couldn't dynamically expand your array based on areas that your player discovers. And so it could potentially eat up a lot of memory, so you would want some way of pushing some of that data out to the hard drive, or to isolated storage rather, on the phone. And then as a player enters a certain area that they've explored before, then you would need to reload that chunk of data. You wouldn't necessarily want to have one gigantic array of memory at all times. You would want to page through it somehow. But yeah, you could absolutely create an endless game like that. Show how, let me expand this a little bit here. Show how you set up the map grid, please. Okay, certainly. Let me flip back to the code. So our map grid is right here. And all we did was we created an integer array called map, and then I actually pre-populated it, which you don't have to do it this way. You could programmatically build out your map based on various criteria. Maybe you want to create a utility that creates random dungeon maps or something, or something like that. And then you could actually pass in some information like how wide the map needs to be and how high it needs to be, and maybe a frequency of rooms. If you wanted to have, say, a range of, give me a lot of trees or little trees, then all of that you could do via parameters, and then have a routine that populates the areas of the array. But for the demo, we just went ahead and pre-built it. But it would be very easy to change the way it looks just by changing these numbers. And so maybe if I wanted the path to fork, instead of just going kind of zigzag like this, I could come in here and change that and that and that. And go over here like that. And then if we run it again, we flip back over to the emulator, you can see that our path now forks. Of course, it's also running through a couple of trees, but it's literally that easy to change how it gets this way just by changing the data. Now, in a more complex game, you would certainly use a different approach as far as how you build out your maps. But this also opens up a really interesting possibility, because if you're working on a really big game, maybe you've got more than one person. God forbid, you have more than one person on your development team. Wouldn't that be nice? And one person is focusing on the core game stuff, and another guy is responsible for content. And so you could build a very simple map level editor that just spits out a text file full of numbers, and you could give that to your content guy, your creative guy, and let him go build a bunch of maps and just save a different file for each level. And you could build a little drag and drop tool to let him design the entire map visually, and then it's just going to save a text file full of numbers. And then you read that text file in as part of your game, and all of a sudden, there it is. It's part of the game now. Okay, what was the next question? Could you please provide the ISBN number for your book? I actually don't have it memorized, but it's really easy to find. It's Professional Windows Phone 7 Game Development. It's from ROX. Let me see. I can pull up the ISBN real quick. Let me go on to the next question while we're doing that. So I missed how the array was being initialized. I think we covered that one. Do you recommend building a level editor before building the game? Hey, great question. It depends, right? So if you're building a really big game or you have multiple people working on your game, then I think it's a great idea. Absolutely. Anything where you can divvy up the work like that is definitely going to be a big plus. Even with small games, really. I mean, Nick Graveland has written a lot of small games, and he says he almost always builds the tools first, because building the tools that enable him to build the level maps and stuff like that give him a better idea of what kind of data he's going to be working with once he starts actually building the game. And that's a really good way to approach it. So I would definitely encourage building out your tools like your level editor and stuff like that whenever possible. Okay, so that ISBN, let me get that here for you.
Hey, Chris, I found it for you and copy and pasted it into the chat.
Oh, terrific. Okay. Well, moving on to the next one then. Let's see. What was next? So yeah, I would definitely recommend building a level editor before building the game. Any advice for new game developers? Start small. That's the biggest one. We see a lot in the XNA forums. We get a lot of people come in, they've never written a game before, and they've got a friend or a brother or somebody, and they're convinced that they're going to build the next World of Warcraft, and they want to know how exactly to create a project in Visual Studio. And so what you see here is you get people with huge ambition, and we don't necessarily want to discourage that ambition, but most of the time if you start too big, you're going to get frustrated and you're going to give up without ever creating anything. And so a much better approach is to start small, and even though there's a million clones of Centipede and Yahtzee and Blackjack and Tetris and all that stuff out there, those are good exercises in taking the time to create those type of games and learn various game mechanics and learn how to optimize your code, and all of these things will help you significantly as you move on to bigger projects. And so definitely start small and work your way up, and don't be afraid to ask questions. A lot of people think that if they ask too many questions, it's going to reveal their big plan and their great idea. And not to be a cynic, but chances are, if you've thought of it, somebody else has thought of something similar, and just because you share your idea, it doesn't mean that there's 50 million people sitting out there waiting to jump on your good idea and go implement it. Implementing it's the hard part. There's a lot of ideas out there. The hard part is making them work, and that's what studios and game companies are looking for, is the implementation, not necessarily the idea. They've got vaults full of ideas. So definitely don't be afraid to ask questions, get help, use the resources that are out there, the forums, the starter kits, everything that you can find on the Create site and 500,000 other game development sites, and definitely start small. Can 2D and 3D be mixed in the game as you can on a PC-based game? Yes. So you can absolutely, totally create a 3D world-based game and then have two-dimensional graphics as an overlay. And so a good example of that might be where you have a three-dimensional game where you're flying through space, but then you're using two-dimensional graphics for stuff like the crosshairs that you're using to aim with, or the sprite font that you're using to display your high score and your status messages and stuff like that. You can definitely blend those. Did you set up a 3D camera with a camera position and look at parameters? How hard would it be to add zoom in and out? So I actually did not set up a 3D camera. In this case, when I refer to a camera on this, I'm just talking about the viewable area on screen. And so as we're moving our image around, we're only drawing a subset of what's actually being built. That's a little different than a 3D camera. As far as zooming in and out, if you were using a 3D camera, then your entire world map would actually be constructed differently, because you'd be using a world matrix instead of just a two-dimensional array. But once you've got that in place, then doing the transformations to zoom in and out wouldn't be that bad at all. How can I get the example? So that'll be on my blog, again, www.blogismaximus.net, probably by tomorrow. It says, I've purchased several books by Rox already, and they've been a great resource. I will search online. Oh, okay, well, thank you. Terrific. A lot of the code that I did in my previous webinars was also in my book, and so if you're looking for a more in-depth explanation of previous code that I've done, then definitely check out the book, because we go into it pretty deep. This particular demo is not in the book, but I'll make sure to have the code up online really soon. Can you please explain the back buffer a little? Sure. So the back buffer is basically the video memory. And in our code, let me scroll. It was in our game class. Let me scroll up. We're setting our back buffer to the width of our tile map, which is going to be the number of squares in the map, times the width of the texture, which is 101. And so that gives us basically a giant image in memory that we're drawing to. And then we do the same thing for the height. So the height of our tile map being the number of tiles in the, or the number of rows in the array times the height of the image itself. And you'll notice that the height is actually a lot different than the width, because even though they look like they're square, there's an area of transparency at the top of the image, so that makes it a little taller. And so we're setting that video memory in area. I am struggling with math. I don't want to learn everything. Any tips on focusing on the right stuff that I can apply towards game development? Well, it depends heavily on the type of game development you want to do. If you're looking to do 3D type game development like World of Warcraft and some of these, Halo type games where you're in a 3D world, well, then you need to take a lot of math. I mean, there's just no way around that. XNA gives you a lot of helper classes, and it does a lot of stuff to make your life easier, but 3D math is brutal, and you need to have a good foundation in math if you want to do 3D games. Now, 2D math is not nearly as hard. That's pretty much adding and subtracting and a little bit of multiplication. You don't need a whole lot of math for that. I'm not doing any trig or calculus or anything like that in this. I'm just keeping track of basically a two-dimensional grid and where am I in that grid. And so that's pretty straightforward. As far as focusing on the right stuff that you can apply towards game development, again, it depends. If you want to do your own art, then you're going to need some art classes. If you want to be a developer, then you need to focus on having a good comprehensive understanding of the programming language, which in the case of XNA is C# or VB, although I would say 95% of your resources are going to be in C#. So either of those will work, but you'll probably find it a little easier to find help if you're using C#. And then, of course, if you're developing a game that has any kind of content to it in terms of story and dialogue, then having a good grasp of grammar and creative writing skills goes a long way. But if you're just looking to make Space Invaders, then mostly you just need some art ability or have a friend with art ability. Have you ever found yourself in a spot where you wanted to go deep and dirty in something akin to assembly code just to squeeze out a few more frames per second from XNA? Not really, but that may just be me. I tend to focus mostly on the 2D stuff. You may not have heard that part where I said that 3D math is brutally hard. I was speaking for myself. I'm not a huge fan. I mean, I love 3D games. I love playing them, but I don't really enjoy working on them. So for what I do, I don't really dig too deep. Now, XNA is DirectX under the hood, so you wouldn't necessarily need to use assembly, but there may be cases where you need to do some DirectX magic. Although for the phone, you're pretty safe just sticking with XNA, honestly. You don't really need to go deep and dirty, as it were, to squeeze out a few extra frames. The phone is fixed at 30 frames per second. The Xbox is fixed at 60 frames per second. It's really only PC where it's kind of wide open, and that's totally hardware driven. So depending on your PC, you could be getting anywhere from 10 frames per second to well over 100, depending on your video card and your processor and the amount of memory you have and how well the game is coded, that sort of thing. What's the purpose of using the transparent padding on the image if you are overlaying over it anyway? Wouldn't using an image without transparent padding reduce memory usage? Certainly. I did not create the images. So I borrowed, with permission, the images from Lost Garden, and there may be cases where it makes sense to have that transparent padding around it. In the case of how I was using them, I could have probably popped them open in Paint.net or a similar program and cropped them down to just what I needed. But I kind of like the flexibility that they offer with having the two-dimensional surface with the three-dimensional look. And so that's why I used them. But yeah, valid question. they take up more space the bigger they are, and so if we cut that out, then they take up less space. Can you explain the different sprite batch draw modes, back to front, front to back, and others? Okay, well, the order in which you draw your sprites, which your sprites are your two-dimensional objects, or your two-dimensional graphics, the order you draw them in has a direct correlation to how they appear on screen. And so if I draw my ground first and then my decals afterwards, then that's the order they're going to appear. But if you use a different draw mode, where say you reverse that, then they're going to draw. So remember that nothing draws until you close your sprite batch. So you're going to make a whole bunch of calls to draw. You're going to draw your tile, you're going to draw your decal, maybe you're going to draw a monster, and then you're going to close that sprite batch, which we're doing in our game class. And then all the calls get processed. And so it's a mode of the sprite batch, not the individual draw call that it sets either back to front or front to back. And so we can actually flip that around, and I could make the calls in a different order if I wanted to do back to front, for example. Any opinions on the new Mango update, given the mixing of Silverlight and XNA in the same project? Yeah, I think it's great. I haven't had a chance to dig into it too deeply, but basically it's going to give you the ability to have a Silverlight app where you have a page within that Silverlight app running XNA. And there's a couple of really good scenarios for this. Maybe you have an app that isn't necessarily a game, but needs to be able to leverage high-performance 3D graphics. And so you want to use XNA for that because Silverlight just isn't suited for it. And so being able to embed that within your Silverlight app, but still have the ability to overlay Silverlight controls onto that page makes it very useful indeed. So if we go back to the example I mentioned earlier, maybe you wanted to create some type of random dungeon generator. Okay, you could actually do something very similar to that with this tile map demo, where you pass in some parameters like how big the dungeon is, how many levels deep, how cluttered it is with rooms. Does it only have 4 or 5 rooms per level, or does it have 20? You know, and you can actually have all of those controls, drop downs and stuff right on the screen with your map. And so you render a map and you don't like it, so you click the drop down and say, give me 8 rooms per level instead of 12, and then it re-renders automatically after you make your selection and redisplays right there with your controls right above it. And you know, that's something you can't do currently, right? Because XNA doesn't have any concept of UI controls, and Silverlight isn't really suited for the high-performance graphics side of thing, especially the 3D stuff. And so being able to blend the two like that gives your users or your gamers a much better experience. Next question. I have run into many issues importing FBX content into XNA. Can you suggest any good resources to read up on the topic of FBX as related to XNA? Nothing really springs to mind. I haven't really done much with that. I know there's a number of good books out there, though. I know James Silva wrote a chapter of an older XNA book. I think it actually focuses on XNA 2 or 3. That he talks a little bit about that, and it's not something I've dealt with specifically. So unfortunately, I may not be much help. But if you search around for James Silva or Nick Hargraves, no, excuse me, Sean Hargraves, either one of those, I think have some blog posts and that sort of thing about stuff they've run into with that. What does the abbreviation decal mean? It's actually not an abbreviation. So a decal is another word for a sticker. Okay, so in the concept that's being used here, you've got your tile, which is a piece of terrain like earth or water or sand or stone, and then a decal, it isn't really terrain, it just kind of sits on top of the terrain. So I'm using it in the context of a sticker or a label, where you're just basically putting that on top of the terrain. Yeah, decal basically equals sticker. Is it harder to tombstone restore a game compared to a Silverlight app? I wouldn't say it's any harder. You know, what you need to do, if you've got a game and you get a major interruption like a phone call or something like that coming in, then it's going to fire an event saying that your game's about to terminate, and you're going to need to write some code that takes your game state information, however complex that may be. And so that's really the defining factor here is if you've got a really complex game with a lot going on, then your game state is going to be equally complex because you're keeping track of what the player's doing, what the enemies are doing, the state of maybe any buildings or maps or treasures or quests or all that. And it can get incredibly complex. But you're going to need to take that game state and write it out to isolated storage. And then that way when your game exits and they do whatever they're going to do, when they come back in, you're going to want to look in isolated storage and see, do I have a save game or some game state that's been persisted out here? And if I do, let me give the player an option to either resume from that or just start a new game. But as far as harder, it's only harder if your data is harder to serialize, I guess, would be the best way to explain that. If you have a lot of really complex game state information, you're going to want to structure it in a way that is complementary to serializing the state of the game. Most current games don't seem to store game states. Game state can mean a number of things, right? It could mean something as simple as what level you were on, or it could be something much more complex in terms of if you have an RPG with a lot going on, it could potentially store all of that. Some games are basically just die, and just force you to reload from the last manual save point. There's one game that I play a lot. I had an iPhone before I got my Windows phone. There's this game called The Creeps, which is a tower defense game that follows a path. And if you got a phone call, it would pause the game, save out all the data, and then exit. And so after your phone call, when you went back into the game, if you hit resume, it didn't just bring you back to that level. It brought you back to the exact point in that level with all the monsters exactly where they were, your score and items and everything exactly where they were, and you could pick up right where you left off. And that's just an implementation detail. I mean, that's one way you can do it. Another way would be they would just have to restart from their most recent save point. As an end user, as a gamer, I prefer being able to jump right back into where I left off. But depending on the type of game, that might not always be feasible. Thank you for the webinar. Thank you. Thank you for coming. You're definitely welcome. And of course, let me go ahead and put my slides back up. My email address as well as my Twitter name and my blog URL are all on the screen here. And so if you do have any questions that didn't get covered today, feel free to drop me an email or contact me through the blog. And of course, you can send me messages on Twitter and all that, and I will get the code and the slides posted to my blog within the next day or so, probably about the same time that this webinar goes live for the on-demand viewers, and you'll be able to check it out then. And absolutely hit me up if you have any questions. I'd love to see what you come up with.
Awesome. Thank you so much, Chris. All right, everybody. So Chris's next webinar is next week, July 7th, next Thursday at 10 a.m. Pacific Standard Time on building a pathfinding system using waypoints with XNA on Windows Phone 7. And that webinar will build on this webinar that Chris just did to provide a degree of artificial intelligence for the creatures in your game by creating a system of waypoints they can use to navigate the terrain on your map. So that's next Thursday, July 7th at 10 a.m. And you can register for that and all of our upcoming webinars currently posted through July at devexpress.com/webinars. We do have one more webinar this week. It's tomorrow at 10 a.m. Pacific Standard Time, working with the state machine module. In this session, we'll demonstrate how to take advantage of the module in our project management application. So again, if you missed anything from this webinar, or you want to review any previous webinars or check out hundreds of online product tutorials, you can visit us on the DevExpress channel at tv.devexpress.com. Again, thanks so much to Chris Williams. Thank you all for joining us, and thanks for choosing DevExpress.